We're going to do something a little bit different today. Rather than going through and talking about the basketball court that we used for much of class, I'm going to look at the images that you didn't get to engage with as much in class because it looks at some indirect measuring, which I think is more helpful for what you're doing with your homework. So first we looked at some things that were scale drawings and things that were not scale drawings, and we ended up developing a definition that I've paraphrased into what we've got at the top here. That scale drawings are drawings that accurately represent actual objects. All of the corresponding parts are scaled, so you can tell how the distances relate to each other. You can use a scale drawing to actually figure out what's going on in real life, just as if you had something in real life, you could scale it down to a scale drawing. Scale is the important tool here. A scale tells you how the distances in the scale drawing relate to distances in real life. The scale in the basketball example was that 1 centimeter represented 2 meters in real life, which meant you could double and then change the units to meters, and you knew how long the actual parts in the basketball court would be. In this case, we've got a scale that we're going to need to use some indirect measurement with. We have the information that this distance, we don't know, I don't have a ruler here, but this distance right here is going to represent 100 meters in real life. So this is our scale down next to the Great Pyramid. I can use this to figure out how tall are all of these objects in real life, and also how do these objects relate to each other. But to do this, I need to make some tools so that I can indirectly measure. There are a few different ways you can do this, and I'm going to show you a couple. So one way would be to kind of make yourself a ruler. So if you know that this is 100 meters, take that and use it to measure how tall your objects actually are. So the Great Pyramid would, take one of those and then a part of another one. And if I'm looking at that, I would say, well, it takes one, so that's 100 meters, and it takes part of another one, a little bit less than half, so maybe this would be a 140 meters. To contrast that, the Eiffel Tower takes one full ruler mark plus a second full ruler mark and almost the entire third here. So we would say that maybe this one is going to be 200 and maybe 290 meters. You could also use this then to compare distances. If we stop where the Eiffel Tower stopped and then use that to compare to something like the Willis Tower, we could say, well, here's where the Eiffel Tower stops. This is about where the Willis Tower stops. It takes two of these markers, so it is 200 meters taller in real life, the Willis Tower compared to the Eiffel Tower. So that's one possibility. A second possibility would be to draw yourself some scaling lines. If we're doing this, you're going to want to make sure that your lines are all equally far from each other. You need to have equal distances, and you need to make sure that you have lines that are straight and parallel. So here's how we could do this. We could extend this out, and since I'm working with technology here, I'm going to make this clear, but if you were doing this with rulers, you could, or with kind of creating a ruler, you would want to make sure that your lines are going across equally. You could use a straight edge so that you have straight lines. You could use something that has right angles to make sure you have straight angles. And I'm going to make this transparent so that I can see through it. So this is 100 meters. I can keep going until I've gotten up to my tallest building. So we're now at 400 meters, 500 meters. It really only leaves us with the Burj Khalifa, which is the tallest building in the world, at 700 meters and a little bit above that. So now we could say 100, 200, 300, 400, 500, 600, 700, 800 meters. Our tallest building is just shy of 800 meters. Maybe I would say that's 790 meters. Our CN Tower is 100, 200, 300, 400, 500, 530 meters. Seems, like a good approximation. The Willis Tower is almost exactly 500 meters based off of this. The Eiffel Tower is almost exactly 300.
and the Great Pyramid is about 140 meters, like we had noticed before. You could also use this to look at distances that are different. So going from the CN Tower up to the Burj Khalifa, you could say, well, between the CN Tower and the Burj Khalifa's top, we're going one full one, about half, and then almost an entire. So you would say those are almost 100, 250, maybe about 250 meters taller, the Burj Khalifa compared to the CN Tower. So you can make yourself something that you kind of keep scaling up until you get to the Great Pyramid, or whatever it is that you are measuring, or you could do something like this where you now have made yourself a ruler that you can use to compare all of your objects. And that's how we can use indirect measurements when we're talking about scale drawings. But this only works if your drawings are actually drawn to scale, which means that all of the parts need to be related by a scale factor to the actual objects in real life.